Okay guys, so this is a question from the May 2017 IB exams HL Chemistry Paper 2. Let's read the question. Below are two isomers, A and B, with the molecule formula C4H9Br. Explain the mechanism of the nucleophilic substitution reaction with aqueous NaOH for the isomer that reacts almost exclusively by an SN2 mechanism, using curly arrows to represent the movement of electron pairs. Okay, so the thing about the IB is that from Organic Chemistry, Chapter 20, they love to give you questions where they basically ask you to draw out the process of a certain reaction. This is what they're asking for in this case as well. Let's underline nucleophilic substitution reaction with aqueous NaOH and SN2 mechanism. So first of all, the nucleophilic substitution reaction in the IB refers only to those with halogenalkenes or haloalkanes. For example, here we have bromoalkanes, and we are doing this with NaOH, aqueous NaOH. For a nucleophilic substitution reaction to happen, we need a halogenalkane and a nucleophile, which is an electron-rich species. Where do we get that? From this NaOH. See, NaOH, if we dissolve this in water, gives us Na plus and OH minus. This OH minus is going to be our nucleophile that we're going to use. And for the halogen alkane, we obviously have C4H9Br, but this question is asking you, which type of C4H9Br do we need? Is it A or is it B? And we can find the answer by looking at this, the SN2 mechanism. Now, if you guys recall, we know that the SN2 mechanism and the SN1 mechanism are the two types when we talk about the nucleophilic substitution reaction. This is for primary halogenal alkanes, and this is for tertiary halogenal alkanes. Now, I won't go into, I'll presume that you guys know what these two types are, but just to clarify, for the SN2 mechanism, the 2 means that this thing is bimolecular. So we start with 2 reactants, meaning the nucleophile is the one that attacks and initiates the reaction. For the SN1, we call this a unimolecular mechanism because it is only the halogen alkane that actually initiates the reaction, as we have to wait for the halogen to leave before the nucleophile comes in. So since we're doing an SN2 mechanism, we're going to find a primary halogen alkane from A or B. We can look at A. So the carbon to which the bromine is attached to one and only one other carbon atom. The rest are hydrogen atoms. So this is a primary halogen alkane. We're using A. Just to clarify, for compound B, we have the carbon to which the bromine is attached linked to 1, 2, and 3 other carbon atoms. Since it's 3, this is a tertiary halogenal alkane, and this one would actually go under the SN1 mechanism. Now that we have our isomer and we have our nucleophile, let's start writing the answer. So first of all, we can write this compound out like so. Like that. And since we said that it's a bimolecular reaction, meaning it starts with both the nucleophile and the halogenal alkane, we're going to add the nucleophile as well. Now, this is how, and I'm pretty sure for the SN2 mechanism, you guys remember that these 2 electrons move to the Br. They said use curly arrows to represent the movement of electron pairs. And these 2 electrons from this nucleophile is going to attack the carbon atom here. This happens simultaneously and leads to a very unstable state between the bromine and the hydroxide. This is very unstable, and because just to see here we have a negative charge here, so this is transferred to the whole compound, brackets, and a negative charge to the whole thing. This is called a transition state, and it is very unstable, so the bromine is going to be quickly kicked out of the compound. Like so. Only because over here it had taken the 2 electrons from this shared covalent bond with carbon, it's now going to have a negative charge and it's a bromide ion now. This is what the IB wants you to write down when you have these types of questions. Thank you.